Right. I hope you have done access list, the labs. I hope you understood standard extended access list. This is another important topic called network address translation. Simply, we call it as NAT, network address translation, NAT. What is network address? The address that you use in network layer is network address. What address do we use in network layer? IP address. IP address. We translate IP address. That's what we call it as NATing. Why do we translate IP address? See, I teach in English. Why do I teach in English? So that not just people in Tamil Nadu, people all around the world, I cannot say all around the complete world, the majority of the world population understands English. So what I do is I translate my Tamil knowledge in English knowledge. I deliver it in English. So many can understand. When my video is played in China, they can understand now. When it is played in Africa, they understand. When it is played in Australia, they understand. It is because I have translated. When I put it in Tamil without translation, only a small group in Australia, a small group in Africa, the migrated Tamil people, a small group of European migrated from Sri Lanka and from Tamil Nadu. Only they understand. But when I put it in a translated mode, when I put it in translated English language, not just that small migrated crowd living in foreign country, the entire country, most of the people in Africa speak English. Very good English. People who is selling groundnut and water in roads, they speak very good English in Africa, especially in parts of Nigeria. They'll be selling groundnut and they speak very good English. They are very polite, decent, and they are very good in respecting people. With polite English, they speak. I really like them, African and mostly Nigeria. English speak. Everyone speaks English in Nigeria. Everyone. Right. So what I do is the knowledge I acquired, I might have acquired in Tamil language, but I don't present it in Tamil. When I present it in Tamil, that video will be a waste of time for the other country people. When I put it in English, they learn it. Likewise, in networking, when we use private address, Every organization will use only private address internally. They use private addresses internally. It's like Tamil language. Now, the internet, which is connecting the entire world, the internet that connects the entire world, don't understand that language, right? This is like Tamil. This is like Spanish. This is like Arabic. These are all local languages, private. But if someone wants to do business, speaking in their own language won't help them. They have to translate in English. Only then the business between these three language speaking people will go well. Likewise, in the public internet, the routers will only maintain the routes for public networks. So the routers will not have any route to reach private. If I put it in our analogy, these routers don't know Tamil, Spanish, Arabic. It knows only English. So if someone needs to talk from, let's say, enterprises 1 with enterprises 2 and 3, before sending the traffic out, they need to drop the private address and pick up the public address, which is what we call it as network address translation. Now, from here to here to here, it was only private IP address. But when the packet is crossing the border, before crossing, it drops the private identity and picks up the public address, drops the private address and takes a public address so that the public network will know you and your location and the communication now possible. Every company will have a unique public IP address. For example, 11001. And this company has got, let's say, 33003. And this company, let's say, 89.0.0.10. These are all not private range. Private range is 10.0.0.0 to 10.255.255.255. And then 172.16.0.02, 172.31.255.255, and then 192.168.0.02, 192.168.255.255. Other than these range, all the rest are public. Most of the companies will have one of this. This maybe here, 10 network. Here it may be 772.16 network. Here there may be another 10 network. See, there are chances that two companies have got same address, same network, but they never get conflicted. How? Because when they speak to the public, they don't show their original 10 network, they only show 89. These guys show only 11. So there won't be conflict. There won't be any conflict because they don't show their original 10. If they say the origin, if they show the original 10, then these two will conflict. But that never happens in the world. There are hundreds of companies having same IP address, but never conflicted because their original IP address, the private IP address, are never revealed outside their company. When they come outside the company, they get translated to their own unique ISP provided public IP address. This process of dropping the private identity and taking the public identity is what we call it as network address translation. Without translation, your packets cannot be moved, routed over the public network. Not possible, right? Like I said, without me speaking in English, I cannot take my message outside Tamil Nadu and Sri Lanka. Only Tamil speaking people understands. Rest all the world won't understand. Which means my message is not routed. To route my message, I need to speak the language which everyone understands. So we translate. We translate. See, the very important mission that is given to everyone is go and preach to all the nations and make them disciple. Hey, are you still preaching in Tamil after having good education? You're mistaking. Start preaching in English because God has commissioned you to go to all nations to preach the gospel. If you know English, start preaching in English. Only then you can accomplish what God has given you. Right. Now, let's learn the type of NAT we have. Number one, static NAT, which is one-to-one NAT. Next one is dynamic NAT. which is any to any. That is dynamic net. The third one is dynamic NAT overloading, which is many to any one. Many to any one address. This is any to any, not one. Here it is one. Many address gets translated to single address, which is overloading. I hope you understand the word overloading. Many gets translated to one. Many gets translated to one. That's why it is overloading. That is not the case here. If 10 address is translated, it is translated to 10 different address. Any to any. 10 different address. It is one same address. Here it is not overloaded. Here it is overloaded. That's the difference between this and this. And this one you will understand. It is one-to-one static. I'll be explaining you in much more detail in few minutes, but as of now, you should know that we have three type of NAT. Static NAT, dynamic NAT, and dynamic NAT overloading. Static NAT is translating a private address to a public address. Dynamic NAT translating any private to any available public address. And then dynamic NAT overloading is translating any private to any one, I should say any number of, because I put many, any number of private to any single public address. You know, in this translation, port numbers are involved. So this is also called as port address translation. Port address translation, PAT. Dynamic NAT overloading is also called as PAT, PAT, PAT. Port address translation. Static NAT is one-to-one, one private address you draw, and you put one public address. For example, this is a computer or a server whose IP address is 10.0.0.1 in your inside organization, there are many computers. Three. Now, let's say there is Yahoo here. Yahoo. And there is a roaming user from this company, from this company. Now, you see, he's a roaming user. He's an employee of this company. This employee, he want to access the server from somewhere in the internet. So what we do is we do static NAT. We say for 10.0.0.1, we'll dedicate a public IP address. Let's say 11.0.0.1. And we will not give this address to anyone here. No, we won't give it. It's only binded. It's only dedicated to this machine. You know why? So that the roaming guys, when they ping this address, they will be pinging this. I told you from the internet, you cannot ping, you cannot connect to the private network. Internet will not know where is 10 network. Internet is a public network. Public network should not maintain the routes for private. And it is also not possible. You know why? I told you, not only you have this 10.0.0.1, there are millions of people all around the globe have got this 10.0.0.1. So for whom we will maintain the route in the routing table of the public. So so it is important to statically, manually assign a public IP address so that whoever wants to access the server from outside, they will talk to that public 11.0.0.1. In turn, the translation from 11.0.0.1 will be done to 10.0.0.1. See, this is bidirectional. When I talk from inside to outside, this gets translated to this. When I talk from outside to this address, from public, it gets translated to private. Listen, depending on the direction. When you're communicating from outside the world, outside your company, from somewhere around the world, to the inside of your company, your translation is public to private. So what I'm trying to say, this is just for your understanding. I told you, translating from private to public. This private to public is when you try when you're trying to communicate from here to outside. That is private to public. But static net is bidirectional. Even from outside to even from outside, when you come, you get translated, and this time it is translated from 11.0.0.1 to 10.0.0.1. Only then the packet can come here. Did you understand the word bidirectional? Static net is bidirectional. Did you understand this? Okay. So static net is one-to-one net and it is bidirectional. Now, before we go to the other type of net, dynamic net and dynamic net overloading, I want you to understand the necessity of static net. Static net is needed only when you talk from the office to the outside as well as from outside to the inside office. Whenever you want bidirectional communication, only then you need static net. Otherwise, you should not. Listen, the reason why we have private address is for everyone you cannot give public IP address. For example, in this organization, if I have 1,000 computers, I don't need 1,000 public IP address. I may need one or two or three or four public IP address. That's it. Let's say four public IP address. You see, we are saving lot of address for others to use. If no natting, then we would have not got this big internet today. Because most of us are in private network, big organizations, 2,000 employees. But they did not have 2,000 public IP address. They don't do static netting for each employee. If they do static netting, then you won't have enough public IP address for the entire world. Static netting is only needed if someone from outside also will ping your computer. I'm asking you a question. You are in your home. You are going to YouTube, you are going to Amazon.in, you are going to Yahoo.mail, you are going to Gmail. You're doing all this thing. At any point of time, did Yahoo ping your computer to do something? Are they coming inside your computer and doing something? Never. When you send a request, Yahoo will reply you. That's only a reply. Yahoo is not initiating a connection to you. Your friend is not initiating a connection to you. If he initiates your friend, he's initiating from his private address. It gets translated to public, and public only talks to your public and gets translated to your private. In short, what I'm saying is the main reason why we have natting is everyone cannot be in public IP address. We need to translate to few public address that you got. For example, I have 10,000, I have 1,000 employee. Only for one employee, I have given static net. What about the rest? 999? Only for this guy, I have given dedicated address. What about the other 999? I need to manage with the balance 3 address I have. Yeah. For 999 computers, I need just one or two address enough. Yeah, that is what dynamic net helps us to achieve. You cannot have static net for every computer. Why do we need a dynamic net? So that you can pick any of the public IP address that is available in this three, no, in this three address. One you have given for 10001 statically. So you got balance 3 address. So this 999, when they try to communicate to outside, they go and take available address that is there. What if there is no available address? All three are consumed. Then other have to wait till that address get released. We'll talk about those things later, but what I'm trying to say is we do not do static NAT for all devices and in our organization. Only the device that you allow someone to access from outside to inside, you need static NAT. For example, I gave you example. One server is there in our company. That server, the employee should access from outside. Using IP address you want to reach, not using Google Meet and all. That everyone will, for that there is no need for, that's a different story. That's an application. Even behind that big matting is there, we will come to that later. But now what I'm saying is, if someone directly want to ping to an address to reach the server from outside, then there should be one dedicated address for that server. That's the only reason why you need static NAT. You're working in an organization. Will someone ping your computer from outside? No way. They may ping through WhatsApp, they may ping through Google Meet, but not using IP address. It is not possible for someone to ping your computer from outside because you're all dynamic netted. You are one among 999 in your organization. You are one among 999. Your computers are not statically mapped. You are dynamic netted. Your computers in your organization are dynamic netted. So what you should know by now is static NAT is one-to-one NAT, and it is not done for every computer in an organization, only for those computers, for those servers which need to be accessed by the outsiders. The static NAT is given. So that you can tell the outsider, if you would like to access, use 11001. So they will use 11001, and the traffic comes to 11001 in the from outside to the router. Router says, 11001. I know. You need to go to 10001. It gets translated and then it comes here. Now, what is the advantage of doing this static NAT? You may say, hey, why you do this தேவையில்லாத வேலை? Why can't you put this address directly here, 11001? That's a good question. You see, one reason is we will not have public IP address inside the organization. Why? A kind of security is here. When you do NATing, your original address 10001 is never exposed to the public. According to the public, how your server is identified? As 11001 only. It is not the original address. The public knows only your NATed address, mapped address. In Tirupattur, there is one jewelry shop called BKB Jewelries. Now it is very small jewelry. Once upon a time, that was the biggest jewelry. And there is one good friend there. His original name is different. But in shop, his name is different. All right. He studied in Lions Matriculation School, which is no more in Tirupattur. And when he is there standing in the shop, some people will talk about him thinking that he is a different person. Why? Because he has got two names. People who studied in school with him knows one name, which is not used in shop. So now this fellow, this friend has grown bigger, stout, gunda, and he's standing there. And this guy who studied with him long back, he couldn't identify. He comes and talks in the shop that I know this person, the owner of the shop. Actually, he is right there, and he is giving different name. So what I'm trying to say here is, when you have two names, your original identity can be easily hidden. That protects most of the business people actually. When they use two names, it protects them. In China, I was surprised. China is a communist country. And when I was teaching in Ericsson in Shanghai, a person named Arun. What? Aaron? Your name is Aaron? Yes, my name is Aaron. He said, my name is Aaron. I was surprised. How is it possible, man? Then he says, that's my English name. So everyone has got an English name. Aaron, Moses, John, Jacob, even though they don't belong to the Christian community, they don't know who Aaron is, who Moses is, but they have the names like that. The original name is different. So when you go to the office and say, I want to meet Aaron, they will be confused. Who is Aaron? But his English name officially it is Aaron. I was surprised. So when he used the translation from private to public, your original 10001 is not revealed to outside. So if someone is trying to attack, the attack packet will come only to the router. And the router knows what it is. It is an attack packet. It won't allow the attack packet to go inside. So that attack never happens to the server. It comes only up to the router. You see, this is one advantage of doing static NAT. You can hide the original identity. Static NAT is one-to-one. Is it interesting? Do you have any question? Only static NAT is bidirectional. Other NATs are unidirectional. We'll talk about that when we go there. Only static NAT is bidirectional. So whenever you want bidirectional communication, you have only one choice, that is static NAT. Good question it was. The other two NAT we will go in more detail tomorrow, but I'm just going to introduce you to the other two NATs. The details of other two NAT, I don't want to put today and make you pressurized. I'm just going to introduce it to you. Dynamic NAT. See, on the edge router is your organization. You got many computers. On the edge router, we create an address pool. See, one NAT we have already given, no, for this 10.0.0.1, we have given already on dedicated address 11.0.0.1. So the remaining address 11.0.0.2, 11.0.0.3, and 11.0.0.4, we create this address pool. And then we say all these. How do we say all this? We use an access list to say all this. That's why I am teaching NAT after access list. I told you when I was in access list class, I told you we need access list to do NATing. Yeah, for dynamic NAT, we need access list. So using access list, we'll match all these computers and we say if a match happens, then they can use any one of the address from the pool, any one address. Sometimes this guy will be using the first address, sometimes this guy will be using the second address, and this guy will be using the third address. And when there is fourth computer, it has to wait. There is no address available in the pool. And let's say this guy finishes using, then this guy will be using dot three. So what I'm saying is, it is not permanently given. The address from the pool is not permanently given for any 1 year. Whichever wants to communicate outside, it will come and see what is available and it will use. That's why traffic from outside cannot be initiated, because to what address you will initiate? Sometimes this address will be with this guy, sometimes the same address will be with this guy. It is not permanently mapped like a static net. So dynamic net is unidirectional. Only from inside you try going out, you get translated to any one of this address and the reply comes back to you. Now the problem with this dynamic net is, as I said, if there are 3 addresses in the pool, only 3 out of 999, only 3 at a time can communicate to outside. All others have to wait. To avoid that, we go for the third method called dynamic net overloading, or PAT, in which port number will also be included so that all 999 can use single address from the pool. You don't need too many address for PAT. This is what we use in the real world. We use static NAT and this. In the real world, we don't use dynamic NAT. We don't use dynamic NAT because if there is only 3 address, only 3 can go online at a time. Others have to wait, which is a long wait time, slow communication. To avoid that, we go with the third method called dynamic NAT overloading or patting, where many can be mapped to a single address along with the port number. How it works and all we'll discuss in our next class. But I'm trying to tell you that for overloading, you don't need too many addresses in the pool. Just 1 or 2 addresses is more than enough. So in the real world, dynamic net overloading is used. And wherever you want bidirectional communication, static net is used. The second method, dynamic NAT, is not used in the real world because it is practically very slow because of the long wait time. Mhm. Right. So with this, I'll stop today.